Hi, my name is Maddie Butler, and today I will be demonstrating the intermolecular forces between molecules. The ingredients I will be using for this lab include wax paper, ethyl alcohol or ethanol, olive oil, ammonia, tap water, distilled water, acetone, 90% isopropyl alcohol, and cotton balls. My dropper did not come in the mail, so I'm going to be using like this, like 1/8 teaspoon to measure it. I'm not going to be using a full 1/8 teaspoon, just like a little bit of it. So I'm taking a piece of wax paper and I'm just going to label where I'm going to drop each of the substances, like so. I'm also going to be using my watch to time how long it takes for each of them to evaporate. I'm going to start by pulling my hair out of the way with a little clip and wearing my safety goggles. So my ethyl alcohol already came with a little dropper, so I'm just gonna do 1 drop of this on my paper right above where it says ethanol. I'm gonna drop it and press start. And now I'm gonna wait and I will check back in after it has evaporated. So ethanol is just like a white clear substance, and I've already calculated the molecular weight, which is 46.0414 grams per mole. So while that one is still evaporating, I'm going to go ahead and take my next one and record what time I started it at. That way I can subtract it when it finishes. This is going to be kind of difficult, but I'm just going to measure out a little bit. Okay. Taking this much, and I'm just going to pour it. On there. So the olive oil is like shiny and like yellowish, and the molecular weight was not available on this substance. So the next substance I'm doing is ammonia, and I already went ahead and poured some of it in this tinier one because the jug was really big, and I figured this would be easier to portion. Okay, so I'm just doing like that much, pouring it on there, and I cleaned the little scoop in between. That way there would be no cross-contamination. So the ammonia is clear and smells very strong. Okay, clean my thing again, and I'm taking my tap water, which I just poured into the speaker. I'm taking that much. Oh, I spilled it. It's okay, it didn't go in any of the other sections. I'm just gonna pour it there. So water is also just clear. Okay, and my next substance is the deionized water, which again I poured into this because it was in a big jug and I didn't want to spill it everywhere. Okay, taking about this much and just putting it onto the paper. So my next substance is the 90% isopropyl alcohol. Take this and pour a little bit of it in here. That much. Pouring it onto its spots. 18. and recording the amounts that I started at. Oh, that is pungent. Oh Lord, close that. And my last substance is this acetone, which again, just pouring it in the clean scoop and pouring it onto the paper. 1222. Okay, and I'll check back once the first one starts evaporating. Looks like this is clear and also doesn't have as much of a bubbly surface. While I'm waiting, I'll go ahead and explain my setup. So I have my research plan here in my chart, substance, evaporation time, observations, all the substances listed, all my observations listed, and this is where I'll put my time. And then I put the starting time of when I put it down. That way, when I get the ending time, I will subtract this from it and get the amount of time it took. On my first page, I have my purpose stated, all of my resources, so this is all of the substances, SDS, that I cited. Then all of that little details about each substances, so their formula, molecular weight, density, melting point, and boiling point. And then here I have all of the hazards listed for each of them, and my pre-labs questions start here and go to this last one. Yeah. The first one to dry up was the acetone. We're at 2121. Converting these values into seconds, here's the finish time and the start time. So that's 720. So 540 seconds. Let's write that here. The next one to dry up was isopropyl alcohol at 2455. Converting that into seconds, it's about 1440. Here's my starting time in seconds. 660. So 780 seconds. Followed shortly after by the ethanol, which was at about 2605. And since I started this one when I started the clock, that's about 1560 seconds. So now it's been longer than 25 minutes for all of these, so I'm just gonna write greater than. I waited for this one just because it was getting smaller, but these ones haven't really made a dent. Bruh. So since it's been longer than 25 minutes for all of these, and they haven't really gotten any smaller, I just wrote greater than 1500 seconds. This one I waited a bit longer on because it was getting smaller. These ones haven't noticeably changed, so. I'm cleaning up like any good chemist would. For part 2, I'm moving locations because I have a darker countertop here. And I'm just going to be taking each substance on a cotton ball and just swiping it and seeing how long it takes to evaporate then. So here I have all of them labeled so I can keep track of which one I swipe where. And once again, I'll be using my little stopwatch here. So my first substance is ethanol. So I'm going to take a little bit on here. And I'm just going to swipe it across up here so I can see how long it takes. I literally can't tell. Okay, so that evaporated literally right as I put it down. So I'm just gonna write like 2 seconds because it literally went right off. Okay, and the next one, so I use this cotton ball, is the olive oil. And watch, this one's probably gonna take longer. Yum, okay. It's just... I'm gonna use my flashlight to see it. So that one's gonna take a little bit longer because olive oil is more fatty. So there's more bonds to break. in order for it to evaporate. So the next one is ammonia, which I have here. I'm gonna pour this into this so that way it doesn't get everywhere. Smells absolutely terrible. All right, dip that in there. We're at 103. Let me get it down so I can like see it. 103. And counting. I'll come back when it's done. Okay, so that took like 10 seconds for the ammonia. The olive oil is still going strong because it's gonna take longer, even if it does even evaporate at all. All right, use that one. Tap water. Dip that in there. Oh, that was too much. Okay. Now I'll wait. So we were at like 210 when I started it. So I'll come back when it's done. Okay, it was like 250 when it stopped. So that's 40 seconds. And now for the deionized water, which I'm gonna pour in the thing again. Okay, so I just pour some of that in here. And I'm gonna take it on a cotton ball and just swipe it. I'm like 330 right now. And, oh, that one's going a lot faster. It's gone. So it's 350. I said what, 340 or 330? I think I said 340, so that's 10. Okay. And isopropyl alcohol is next. So that's this one. Taking a little bit of it on here. We're at 420, 430. And it's already gone at 437. 7 seconds. And the last one is my acetone, which is here. Ooh, strong. Okay. This is gonna give me a headache. I'm gonna close it. I got 5 of 7. And as I expected, it went up almost immediately. So I'm gonna put 1 second because I knew that acetone evaporates very quickly. Okay, I think the olive oil is still, actually, it's still there. I'll come back when it's done. Okay, so the olive oil just finished and I'm at like 540. And I started it when it started, so let me convert that into seconds. So that's about 300 seconds, so I'll write it down here. And my observations are all the same, so. And now I've finished with my lab. I put all of my chemicals away and cleaned off my countertops, so my mom won't get isopropyl alcohol in our dinner. Thank you all for coming on my wonderful, very interesting laboratory experiment. See you next time for episode 2, which I will be showing you the molar mass by performing a freezing point deprivation experiment. So stay tuned. Stay tuned.